this experiment, we can determine the acceleration due to gravity by studying the motion of free-falling body. The apparatus that we'll be needing are mirror stick or steel tape, marking pen or chalk, ball or metal ball, and stopwatch.
Procedure: measure the height 1 meter, 1.5 meter, and 2 meter using steel tape. Mark 3 heights on the wall with a marking pen. The second step is drop the ball from these heights and record the time it will take the ball to reach the floor. Perform 5 trials for each height.
So here is the result in experiment number 4. We got the average time of 0.516 seconds in the first meter, the second meter is 0.606 seconds, and the last meter is 0.6 seconds. The formula for height experimental value is 1/2 times gravity times t squared, where gravity equals to 9.81 meter per second square and t stands for average time. And we will get 1/2 times 9.81 meter per second square times 0.516 second square equals to 1.306 meters. The second one is 1/2 times 9.81 meter per second square times 0.606 second square equals to 1.8013 meter. The last one is 1/2 times 9.81 meter per second square times 0.6 second square equals to 1.7658 meter. Here is the result in height experimental value. The first one got 1.306 meter, the second one got 1.8013 meter, and the last one got 1.7658 meter. Calculate the percent error for each height. The formula for that is EV minus TV divided by TV times 100%, where PE stands for percent error, EV experimental value, and TV is true value. That will be 1.306 meter minus 1 meter divided by 1 meter times 100% equals to 30.6%. The second one is 1.8013 meter minus 1.5 meter divided by 1.5 meter times 100% equals to 20.09%. While the last one is 1.7658 meter minus 2 meter divided by 2 meter times 100% equals to 11.71%. The result for percentage error is the first one 30.6% and the second one is 20.09% and the last one is 11.71%.
Our conclusion and observation: the experiment was conducted successfully and we were able to figure out what the acceleration due to gravity was. The acceleration due to gravity on Earth is 9.81 meter per second square, which is only constant Earth. Any object dropped at the same elevation will hit the ground at the same time, neglecting air resistance. Smaller objects such as the ball we used in the experiment can accelerate faster but have less force of attraction of gravity. On the other hand, the larger object cannot accelerate faster but has a strong influence of gravity. In the experiment we conducted, we measured different heights throw vertically upward the object, and the result is they will have different times of falling until they reach the ground. This experiment has shown the acceleration of free fall is independent of the mass and the height thrown by the falling object. In this experiment, we will know the relations of masses and accelerates, perform the application of Newton's second law of motion utilizing the simple Atwood's machine. The apparatus that we'll be needing are set of weights, stopwatch, pulley, steel tape, and string. Procedure: set up the Atwood's machine as shown in figure 7. The height is 1.02 meters, the weight of M1 is 1 kilogram, The weight of M2 is 0.85 kg. Set up the Atwood's machine, assign different values from M1 and M2. Be sure that M1 is greater than M2. Allow M1 to fall a distance h from near the pulley to the floor. Measure the time M1 reaches the floor, repeat 5 times, and take average. Here is the result. We got the average time of 1.75 seconds.
Calculate the value of experimental acceleration using the formulas shown below. AEV equals to 2 times height divided by t average square. And that will be 2 times 1.02 meter divided by 1.754 seconds square. The answer that you will get is 0.6631 meter per second square. Determine the value of acceleration using Newton's second law. ATV equals to m1 minus m2 times gravity divided by m1 plus m2, where gravity is equal to 9.81 meter per second square. And that will be 1 minus 0.85 times 9.81 divided by 1 plus 0.85. Then you will get the answer of 0.79541 meter per second square. So we got in acceleration the result of experimental value, which is 0.6631 meter per second square, while the true value is 0.79541 meter per second square. Calculate the percent error. The formula for that is EV minus TV divided by TV times 100%, where PE is percent error, EV experimental value, while TV is true value. And you will get the answer by 0.6631 minus 0.79541 divided by 0.79541 times 100%. You will get 16.63%. The conclusion and observation in experiment number 5 is, the experiment we conducted has an objective to know the relation of masses and accelerations. We performed the application of Newton's second law of motion utilizing the simple Atwood's machine. The net force acting on the system of both masses is determined by the acceleration of an object on the net applied force and the mass in Atwood's machine. The difference in weight between two hanging masses, this net force accelerates both hanging masses. With the heavier mass accelerating downward and the lighter mass accelerating upward. In our conclusion, using the Atwood's machine, the weight of the two objects can determine which one will be accelerating downward and upward. Thanks for listening. I hope you learned something new from this video.